From the same paper, we have another question. This is March 19, Indian version of the statistics paper. And here, the first question number 6, it says the results of a survey by a large supermarket show that 35 of its customers shop online. Okay, this is the information that we have. 6 customers are chosen at random. Okay, we're given a specific number. So this can be our n. So this, I doubt this is going to be a question from the binomial distribution. So it says find probability that more than 3 of them shop online. Yes. So we are going to assume that the whole population has been divided into two categories. One, those who shop online. Two, those who do not shop online. Okay. So we can say that X is binomially distributed, and we are going to, like, 6 customers are chosen, and the probability for someone to shop online is 0.35. You will write it like this first of all, and then it says find the probability that more than 3 of them shop online. So we have to find the probability X is more than 3. Guys, you have to be very careful with this equal mark over here. It says more than 3, so it's clear that we don't have to use the equal mark here. It is more than 3. So we have to find this probability more than 3. So this is going to be probability X equal to 4 plus probability X equal to 5 and probability X equal to 6. And this will be 6C4 and 0.35 raised to power 4. When when you write this, you must mention here that your n is 6. Okay, your p is 0.35, and your q is going to be 1 minus 0.35. That is going to be 0.65. So we'll be using that here. So this is 0.65 raised to power 2, and then you have 6C5, 0.35 raised to power 5. We have to write all of this. Okay, and then you have 6C6, and let me change the color here, into this 0.35 raised to power 6 and 0.65 raised to power 0. Next, we have to use the calculator. So after using the calculator, we get this 0.117. That is a probability that more than 3 of them shop online. Okay. We move on to the next part. It says for a random sample of n customers, the probability that at least one of them shop online is greater than 0.95. Okay, for a random sample of n customers. So we can say, okay, there is another binomial
Sir,
distribution. Yes, beta?
मेरा आंसर 2.117 आ रहा है.
It cannot be 2.117. The probability cannot exceed 1. So you better check your working, okay? So it says for random sample of n customers, so there is n. So again, it says it is being talked about the shopping online, so we use the same probability. So now we have here the n is n, obviously, and p is the same 0.35, and q is going to be 0.65. And it says, okay, um, it says the probability that at least one of them shop online. So probability y is greater than or equal to 1. At least one is greater than 0.95. This is greater than. That is how you will be writing this. The probability that at least one of them shop online is greater than 0.95. Find the least possible value of n. So when it says least, so this is obvious that we have to have an inequality over here. So Now, greater than or equal to 1, this n is not clear that what is this number. So you see, we can say that, okay, when it is greater than or equal to 1, we can write the same one as 1 minus the probability y equal to 0. And that is greater than 0.95. I hope it makes sense. Like if you have this, like you see, this is always like, it starts from 0, 1, 2, 3, and we're not clear how much is this, and he's asking, he has given this that at least 1. So from this onwards, you have the probability which is greater than 0.95. So if you have this probability, you take it off from 1, it is going to give you the same result because they're both the complements of each other. So 1 minus probability y equal to 0 is going to give us the same thing. So I can write it as a 1 minus nc0 0.35 raised to power 0, 0.65 raised to power n is greater than 0.95. Okay, and we know that nc0 is 1, this is 1, so we are left with 1 minus 0.65 raised to power n is greater than 0.95. I move this one to the other side, so this is going to be minus 0.65 raised to power n is greater than minus 0.05. So when you cancel the minus with the minus, the inequality sign has to be changed. Don't just change this quickly. This can result into a mistake here. So this is going to be less than this 0.05. And then you apply the log on both the sides. This is n ln 0.65 is less than ln 0.05. Now we are going to move into the most crucial step here. When you take the, divide both the sides with ln 0.65, remember ln 0.65 is a negative value and ln 0.05 is also a negative value. So this sign of inequality will change again. This will be n is greater than ln 0.05. You will not realize this if you just use the calculator directly. But remember, they are both negative. So this sign of inequality has to be changed. So this is going to be ln 0.05 divided by ln 0.65. So we have 6.95. N is greater than 6.95. So we have to give the least possible value. So the least possible value of n is going to be 7 then. This is the least possible value of n. Okay. Now I am doing this question for the sake of the last part. Basically, we have done this recently. The last part of this question, if you see, I was more than any other part. I was interested in this part. This is because this is about normal approximation. It says from random sample of 100 customers, use a suitable approximation. Use a suitable approximating distribution to find the probability that more than 39 shop online. So this is where this is what I was waiting for. Okay, so now again we will say, okay, let x is a normal, sorry, x is binomially distributed with 100 as n. Okay, 100 as n, and then again, shopping online is being discussed, so we'll write 0.35, the probability for shopping online. It's just find the probability that more than 39 people shop online. Okay, so we have to find the probability that X is more than 39. So we can find it this using the rules, the formulas for binomial distribution. Okay, so we have to model this binomial distribution as a normal distribution. So if you have to make a check that if we can really do that, you see that your NP should be positive, your NQ should be positive. So if you check that, 100 times 0.35, that is your NP. This is more than 5. And 100 times 0.65 also more than 5. So we can approximate this binomial distribution as a normal distribution. So what we have to do next is we need to arrange the parameters for that normal distribution that we want to bring in. So we'll say, okay, let y is normally distributed with mean. So we know that the mean is NP. So that is 100 times 0.35, and that is 35. So the mean of this normal distribution is 35. And then we need the variance, and that is NPQ. So this is 100 into 0.35 into 0.65. So let me find that. 35 times 0.65. So this is 22.75. So that is the variance we have here. Okay, so from this normal distribution, we have to find the probability. Now here comes the continuity correction. So if you keep this in your mind that, okay, I have this 39 here. So this 39, if this is 39, so this has to be between 38.5 and 39.5. So it is more than, there is no equal mark. So this would be the region that you're going to consider. So this is going to be greater than 39.5. So finding this probability means that you have to find the probability that y is more than 39.5, and then you standardize this. This is going to be probability z is greater than x minus mu over the standard deviation. Never forget to put the square root over here. So this is, let's use the calculator, 39.5 minus 35 divided by the square root of 22.75. So we have 0.9435. 0.9435. So this is going to be 1 minus phi of 0.9435. We have to go to the table, and I'm sorry, this would be, there would be overlapping here. We have to see 0.9475. Let me enlarge this a bit. 0.94, 1 minus 0.9435, okay. 0.9435. So this is, sorry, this is not phi inverse. So zero point 0.9 is here, 4 is here, 0.94. This is 0.8264, and 5 के नीचे we have 13. So this is 0.8277. 0.8277. 0.8277. 1 minus 0.82. There can be an error mistake made by us while finding this, so you can better check your answers here. 1 minus 0.8277. So that is 1.1723. So this is 0.1723. So we had to find the probability for how many, like what's probability? There are more than 39 who are shopping online. So this is the probability that there are more than 39 people shopping online out of the 100 people. Okay.